All right, today we're going to actually start doing our hypothesis test. I know yesterday we wrote some hypotheses. We talked about finding critical values. We talked about finding test values and rejecting the null hypothesis. And some of those things, they're going to make a lot more sense today. So hopefully yesterday you got a little bit of a background, writing your hypotheses, finding some critical values. Now today we're going to do all the steps. The first hypothesis test we're going to run is a z-test for a mean. So yesterday we talked about statistical tests, and I did mention the idea of the z-test. That's what we're going to use today. We use it when our sample size, remember that lowercase n sample size is greater than or equal to 30, when the population is normally distributed and our population standard deviation is known. So if your sample size is greater than or equal to 30, you could use this test. Or if you have a normally distributed population and you know the population standard deviation. The formula for that, we're finding z-values like we did back in chapter 6 when we first talked about the standard normal distribution. We're finding z-values, and actually that formula looks really familiar to us. It's a formula we used when we did our central limit theorem. So we have the x bar is just our sample mean, our mu, that's our hypothesized population mean, our lowercase sigma, population standard deviation, and n is our sample size. So it's a formula you're already familiar with. We're just putting it in a different context right now. Okay, just a different context. The assumptions, we assume the sample is a random sample, and then either our sample size is greater than or equal to 30, or the population is normally distributed if our sample size is smaller than 30. So again, those assumptions, those are things that we are going to assume, because as we talked about yesterday, we don't actually design the study and conduct the experiment. So we're just having data given to us. So these are a couple things that we need to assume. The 5 steps, we talked about these yesterday. Just a little refresher before we actually dig in and perform all the steps. State the hypotheses, identify the claim. We stated the hypotheses yesterday, but we didn't get specific and identify the claim, so we will do that part today for us. Find the critical values. We did that yesterday. I know I still have about a 50-50 split of if we're going to use table E or if you want to do the calculator function. I think more people as we continue on are going to start to probably use the calculator a little more, and that's cool. All right, so when we compute the test value, we're going to use that little z formula that we just saw. We're going to actually make the decision to reject or not reject. We talked about it a little bit yesterday, how we would do that. Today we're actually going to have the actual data and test value to do that. And then we're going to summarize. So let's take a look at our first example. Let's go ahead and take a little read through. We're going to do all 5 steps. It's been reported that the average credit card debt for college seniors is $3,262. The Student Senate at a large university feels that their seniors have a debt much less than this, so it conducts a study of 50 randomly selected seniors and finds the average debt is $2,995, and the population standard deviation is $1,100. When alpha equals 0.05, is the Student Senate correct? So we're going to take this piece by piece, step by step. Step number 1, write our hypotheses. Like I talked about yesterday, I'll be more than happy to help you write your hypotheses, but there's kind of that general start that we can all have no matter what. At the very least, hypotheses, you should be able to get your H's and your colons, and read through the question and figure out, hey, what's my symbol going to be? Now, I know the section title, we're doing a z-test for the mean. But let's take a read through the question and make sure that we figure out why we're going to use that mu, why it is the mean. It's been reported that the average credit card debt, the Student Senate finds the average debt is. So there's a couple places right there where we know we're dealing with a mean. So we're going to have mu as our symbol. And the null hypothesis always shows there's no difference. It always has the equal to. So at the very least, if you're doing a practice question like, oh, Miss Golly, this hypotheses deal, help me write them, you should at least be able to get that start for me. And then I can help you from there fill in the rest of your symbols. Now, we're given a couple different numbers for the average. And so we want to know, though, if this original one that's been hypothesized, if that's something that we're going to support, or if the student senate is right and it's actually less than that. We are going to use that sample mean when we compute our test value, when we find that z-value. So you want to pick out what they're saying the population mean would be, what they are hypothesizing it to be. And then we have our seniors feel it is much less than. So our alternative hypothesis will be that it's less than, and it will be the same value. Null hypothesis, alternative hypothesis, it will be the same value twice. And that probably is picking out, deciding, is it going to be the 3,000 that's in there or the 2,995? It's whatever they think that original population mean might be. Now the claim piece, the claim we did not do yesterday. The claim is what the researcher's trying to show. So this student senate of seniors, it wants to show, it feels that it's much less. So this senate is trying to claim that what's in the alternative hypothesis, that it's much less. The alternative hypothesis won't always be your claim. A lot of times it is, but it won't always be the case. So it's whichever thing that the researcher is trying to show. And in this case, it's a student senate, and they feel, so they're trying to show that the debt is actually less than that. So that's our claim piece. That's all we need for step one. Your hypotheses, and which part is that researcher, whoever it is, what are they trying to show? That's our step one. Step two, we're going to find our test value. Our critical values. So to find our critical values, we're going to have our alpha, and our alpha is at 0.05. And we have to decide if it's a left tail, right tail, or two-tail test. That's going to be very important for us. I look at the alternative hypothesis. The inequality symbol is pointing to the left, so we're going to have a left-tailed test. So alpha's at 0.05, we have a left-tailed test. I'm going to draw a little sketch. I'm going to shade in the left tail. Remember the alpha that we're given is the area in that rejection region. The alpha is our area. So what we have to find is we have to find the z-value that separates the shaded from the non-shaded. Remember, the shaded is going to be our rejection region. The non-shaded is our non-rejection region. So take a second here, either use table E if you'd like, or actually, no, guys, I'm going to go ahead and I'm going to re-show the calculator steps just to try to make things a little quicker and easier. You like the table, you stick with the table. If you have no interest in this, that's fine. But if you go to second, and then the vars key, we get our distribution menu, and then we just need option 3. Now I know mine shows things a little bit different. I have a few different options on my menu. My calculator is a little bit newer than what some of yours is. The area you're entering in is the area to the left of the z-value you're trying to find, and in this case our alpha is 0.05. Leave your mu at 0 and your standard deviation at 1 because we're talking about the standard normal distribution, and that's what those two things are. And then for me, I could pick center, right. I could pick where I want this to fall, but just to stay with you guys, we're going to go with the left. And you don't need all that extra stuff I have. You actually honestly just need the 0.05 in there. Is all you need on your calculator. And I end up with, and now this is the one that we had kind of the difference on table people versus calculator people. If I use the calculator, I get negative 1.64. If you use the table, you get negative 1.65. Same as last time, this is not going to affect whether or not you're going to reject or anything like that. So use whichever you like. I'm going to stick with what the table would have. I know I just did calculator. But again, if you are using the calculator, go ahead and put the 1.64, guys. It's not going to make or break us at all. So we have written our hypotheses. We've stated our claim. We found our critical value. Now we need to find our test value. And for our test value, we have z equals x bar minus mu divided by population standard deviation divided by the square root of your sample size. And again, that's a formula we're already familiar with, but now we're just using it in a different context. So now the x bar, that population mean, that's where our $2,995, that's where that's coming into play. I know some of you are like, why didn't we put that in our hypotheses? That's our sample mean that we're going to use to help us find our test value. So your sample mean is not going to up in your hypotheses. Your sample mean, we use it to find our test value. We're going to subtract our population, our hypothesized population mean. Population standard deviation, we are told, is $1,100. Divided by the square root, our sample size is, we had 50 randomly selected seniors. So go ahead, just take a minute. What I came up with when I did this was negative 1.72 roughly. So take a minute, rehash through that computation, make sure you're okay with those values. Step 4. Now we're going to make the decision to reject or not reject. If we look on our diagram, and you wouldn't necessarily have to draw out a diagram every time, you don't have to draw the distribution every time. For me, it helps me decide when to reject or not reject. I'm a visual person, I like to see it. So here's our critical value at negative 1.65. Our test value of negative 1.72, is that going to be to the left of our critical value or to the right? It's going to be to the left. It's going to be somewhere over here. It's going to be somewhere over here will be our test value of negative 1.72. That test value, it falls in the shaded region. The shaded region is our rejection region. So test value falls in the rejection region. And again, technically it is called a critical region. I call it the rejection region because it's all about rejecting or not rejecting the null hypothesis. So it falls in the rejection region. So step number 4, we're going to say reject the null hypothesis. Now, if you want to, if you didn't draw a little sketch, since we're just starting out, I'd be fine if on a test for your step 4, you just tell me reject the null hypothesis. Since we're just starting out with it though, you might want to write the little explanation, the test value of test value of z equals negative 1.72. was in the shaded, aka rejection region. So if you want to put that little blurb there, you can. If you drew the picture and wrote the little note, like I said, come test time, or we're taking a little quiz, whatever the case may be, I'm fine if for step 4 you just tell me if you reject or not reject. That's all I need. But for your notes, you might want to have that extra little explanation there. Now, step 5. Step 5 is the summary piece. And the wording of this, we are going to be specific on this. With hypothesis testing, on our very first example, very first data, I want to make sure I'm very clear. We're not proving anything. We're not proving anything. When our claim is in the alternative hypothesis, we're either going to get to say we have enough evidence to support our claim, or there's not enough evidence to support our claim. That's all we get to say. We're not going to prove anything. All we can say is our evidence, we have enough evidence to support it or not support it. That's all we can do. Now, when stating those conclusions, those summaries, we talked about this page yesterday, page 425. There's a little summary table at the top of that page. It is fantastic for helping you figure out how to state that summary. And yes, the summary needs to be specific wording. So in this case, our claim is the alternative hypothesis. We rejected this one. We rejected the null hypothesis. So if we reject that, we get to support the alternative. So we get to say there is enough evidence to support the claim that the average debt is less than $3,262. And yes, that summary, I need a nice sentence like that. We don't get to shortcut this. We don't get to shortcut it. We need all the steps. There's not a different way to do it. So we do need all the steps. Yes, I do need a summary sentence. We do need to say if we're going to reject or not reject the null. We need those steps. We need to make sure we have all those steps. And I'll be very honest, the step that's going to take the most practice. You're thinking, Miss Golly, that step doesn't seem hard. But understanding when you get to support a claim versus when you reject a claim, that takes some practice getting that wording and that summary down. So again, page 425 is going to be a fantastic resource for you. It really will be. Now, I know, here's the reason why I chose this next example. I know you guys are looking at this, you're like, oh, Miss Golly, we got to type all that in our calculator, don't we? Yeah, to find the sample average, sample mean, yeah, we do. But the reason why I chose this is to show you, because I know the questions come up, you get bigger values and things, but I want to show you in the calculator how to shortcut this a little bit. So we go to Stat to put things into our list. And now those of you busy typing already, just hang on just a second. Yes, you do have to enter these in, but take a look. These are all in thousands of dollars. So where you see a comma in the number, put a decimal point there. So instead of having to type out 9500, just make it 9.5. Make the number shorter. As long as you shorten them all the same way, that's okay. So wherever you see a decimal, wherever you see a comma, that's where your decimal would go. So if you're typing in 54,000, just make it 54. Now we're going to have to readjust it back, those 3 decimal places, when we actually do find our stats. But this would just shorten things up for you just a little bit. Once you have all those entered in, let's go to Stat, Calc. Again, make sure your frequency list is cleared out if your calculator is similar to mine. Make sure your frequency list is cleared out. Calculate. Now, the number we're interested in is the X bar. But remember, though, we have to move that decimal point, or we have to turn the decimal point back into a comma. So that's not a big deal. We just have to turn our decimal point back into a comma. We're up somewhere too. All right, so again, we just have to turn, and I'm just going to make the note off to the side what we got. So it should be 82,495.8. I'm going to keep that exact. And remember, since we're dealing with raw data anyway, we go to one more decimal place value than what we're given. So we'd want to go to the nearest tenths anyway. All right, so let's go ahead. Let's take a little read through. Let's do our steps. A real estate agent claims the average price of a home sold in Beaver County, Pennsylvania is $60,000. Random sample of 36 homes sold in the county is selected. The prices in dollars are shown. Is there enough evidence to reject the agent's claim at alpha 0.05? And it tells us what to assume the population standard deviation is. So I'm going to go down here, step 1. Very least. We have our H's, we have the colons, and we read back through the average price. So we know we have mu. We know we have an equal sign in the null hypothesis. And the average price, the mean price that we're looking at specifically is $60,000. Now it says that the agent claims that the average price is the $60,000. So there's nowhere in the question that says anybody's thinking that it's less than that or greater than that. So when that happens, the alternative hypothesis is just going to be stating that the mean is something different. It's not a specific greater than or less than, but it's just something different. Now the claim though, the real estate agent is claiming that the average price is $60,000. So our claim is going to be the null hypothesis this time. The real estate agent's claiming that the average home price is $60,000. So that's what this person, our researcher, is the real estate agent, that's what they're trying to show. Critical value. Critical value is the same as example 1, it's 0.05. But I'm going to go ahead. Oh, excuse me, it's not going to be the same. I take that back. Holy cow. We have a two-tailed test. Oh, rewind that. Here we go. We have a two-tailed test. Two-tailed test means we're going to have both tail ends shaded. Also means we're going to have two critical values. They are equidistant from the mean. But remember that alpha, that area of alpha, 0.05, that's the total shaded region together. So we do have to split it. So our critical values are negative 1.96 and positive 1.96. I like drawing the pictures. I like seeing where the shaded and non-shaded regions are. I like drawing the pictures. Step 3, our test value. Sample mean minus our hypothesized population mean divided by population standard deviation divided by square root of our sample size, and we are given 36 homes. Now again, I know this is a formula we're already familiar with. You guys have done the computation with this before. Get roughly Z is 1.78. Now with a two-tailed test, guys, you get two critical values, but you do not get two test values. You get one test value, that's it. You get one test value. Now step 4, we need to decide if we're going to reject or not reject. So the 1.78 is going to fall somewhere, I don't know, somewhere in here. That's our test value. The test value is not in that shaded rejection region this time. Now it's in the unshaded. It's in the non-shaded, non-rejection region. So step 4, I'm going to say do not reject the null hypothesis. And again, that is all I would need you to put for a step for me on a question like this on your test. But for the sake of your notes, if you want to put why we said that, the test value of 1.78 falls in the non-shaded, which is the non-rejection region. So if you want to put that little explanation there, you can, but again, like on a test or things, I don't need that explanation. I don't need that explanation. So now our step 5. I look at where my claim is. My claim is in the null. When my claim is in the null, it's not about supporting or not supporting. It's about rejecting or not rejecting. So since I didn't reject the null hypothesis, I get to say there is not enough evidence to reject the claim that the average home price is $60,000. So again, hypothesis testing is not about proving anything. The only way you could prove something is if you had the entire data set for the population and you actually found what that population mean was. So this is all about just testing, and this researcher's hypothesis is the average home price is $60,000. So is there enough evidence to reject it or not? If our claim was in the alternative hypothesis, we'd talk about enough evidence to support or not. So it's all about the wording, it's all about where your claim is, how you word your summary. Again, page 425 will give you a great, helpful tool how you word that summary. That was the traditional hypothesis testing method. There is another type, it's called the p-value method, and it deals more with the p-value. P stands for probability, and it's the actual area representing the probability of a certain statistic happening. So it's an actual probability, it's an actual area under the curve. It's not just going to be one test value. It's going to show us an actual area under the curve. Now, when you solve, the steps are just a little different. You state the hypotheses, you identify the claim. Step 2, however, though, you don't find critical values when you find p-value. You find the test value, formula is the same. Then when you find the p-value, you want to find the area that corresponds to your test value that you find in step 2. Left tail, right tail test. Left tail, use the area in table E. For right tail, we have to subtract it from 1. And for two tail, we have to combine the areas that we find in both tails. We make our decision. Step 5, we summarize. Your decision rules, and I will make this visual for you just like we did with our traditional method. I will make this visual for you. If you are given an alpha level, if your p-value is less than or equal to alpha, you reject. If your p-value is greater than alpha, you do not reject. Sometimes there is times when an alpha value is not given for you. There's not a significance level given. There is a box on page 434 that gives you the guidelines for how to handle p-values if there's no alpha value given to you. It doesn't happen often. The researcher typically sets a significance level. They usually have one in mind. But if it does happen, there is a guidelines box for you on page 434. So I just want to do one more example. I want to go through the p-value method with you. And you guys, I think I typed the example out for you, I believe. Yes. On page 437, we're taking a look at question number 20. We have a cable, or it's on the back side of your handout. We have a special cable has a breaking strength of 800 pounds. Standard deviation of the population is 12 pounds. A researcher selects a random sample of 20 cables and finds the average breaking strength is 793 pounds. Can he reject the claim that the breaking strength is 800 pounds? Find the p-value. All right, so step 1, let's state our hypotheses. And I know this is something very, very new for us. So we have kind of those minimum things. At minimum, you should be able to get the H's there for me and the colons. If you read through the question, we have the average breaking strength. So when we see average, we know we're dealing with the mean. And I know this whole section is all about the mean, but you guys know, come test time, we need to be able to know when to use each of these tests. Not only how to use them, but when to use them. So we have null hypothesis always has the equal sign. And in this case, we're being told that this cable has a breaking strength of 800 pounds. That's what we're being told. So that's what is the hypothesized mean. Now, the claim is that the breaking strength is 800 pounds. So again, there's nowhere in this question where it says the researcher or whoever it is feels that the breaking strength is less than that or greater than that. So all we can do for the alternative hypothesis is do the not equal. If there's nowhere in the information we're given that says whoever the researcher is trying to say it's less than or greater than or increase, decrease, if there's nothing in there to indicate that, we go with the two-tailed test, the equal, not equal. Now, what this researcher is trying to claim is that the breaking strength is 800 pounds. So that's the equals. And again, getting that practice, figuring out which thing is your claim, I can definitely help you do that as well. It does take some exposure to this. It really does. It takes practice to get used to it. In this process, we don't get to skip steps. We don't get to shortcut steps. So we do have to make sure we know each step. Step number 2 for p-value method is finding your test value. That's our z. The sample mean, this researcher's sample mean was 793 pounds. Hypothesized mean is 800. We are given the standard deviation of the population is 12. The sample size the researcher used, he had 20 cables. Again, every example we've done today, we've known the population standard deviation. That's how we know to use z. Just like with our confidence intervals, if we knew population standard deviation, we used z. Same thing here with our hypothesis testing. All right, step 3, finding that p-value. I'm just going to jot down, I know you guys have this on your sheet, I'm going to jot down alpha. And it's a two-tailed test. So what I need to do I need to find the area. Oh, I'm sorry guys, I didn't finish off calculating our z-test value. Round to the nearest hundredths, that's what the table in our book is limited to. If you use a calculator to find the area, yeah, you could go more decimal places, but then you're probably going to be a little bit off when you check your answers for the practice questions. So we need the area corresponding to our test value of negative 2.61. Now it's your choice. If you want to use the table, you find where z is negative 2.61, find the area that matches up with that. If you want to do the calculator, I will refresh on that real quick. We go back to our distribution menu. and we want our normal CDF. This is, since it's a negative, we're looking at it over on the left side. So our lower would be negative. Mine puts a 1 there. You don't need the 1. Negative E99. And remember, to get the E, you hit the second key and then the comma key, which is right above the 7. And then you need the 99. The upper one then is our negative 2.61. Paste, and away we go. So the area is 0.0045. That's how many your table in the back of your book will go out to 4 decimal places. It'll go out to the 10,000s. And this might be something where you do just go back to the table. I think the table for this way is very easy to use versus the calculator. So the area, 0.0045. Now, since it's a two-tailed test, if it was a one-tailed test, we would be all set. Left tail or right tail, we would be set. Since it's a two-tailed test, we have to double. I'm just going to make the note here why we're doubling it. Two-tailed test. We need to double the area. Take it times 2. This, ladies and gentlemen, that area, that's our probability. That's our p-value. P-value stands for our probability value. So that's our area that we're looking at. So that is our area. Now, I know we put up there the little rule. We have our p-value. Oopsies. P-value of 0.0090. It's less than our alpha value of 0.01. When that happens, we reject the null hypothesis. Now, I know you're thinking, okay, Miss Golly, I could go through and memorize that table, but can we make it visual? Yeah, we can make it visual. We absolutely can. We can draw our table, or excuse me, our distribution. Now, if alpha is 0.01 and it's a two-tailed test, what's the area in each tail going to be? .005. If it's a two-tail. So then our area, your area actually gets doubled for your p-value. So what would happen, in two-tailed tests, these are a little hard to make, a little more visual. 0.0045 would fall somewhere there, would be the area this way. 0.0045 would be the area that way as well. So those areas for our p-value, if we want to make it visual, we have to resplit it amongst the two tails. So if we want to make it more visual, that p-value, that area, falls in our rejection region. So 0.0045 is smaller than 0.005. So that probability, that area, will fall in that shaded region. Now, if you just want to make it simple, you don't want to draw the diagram and know whether or not to reject, double that area, and compare it with your alpha. But if you want to make it visual, you absolutely can. If you need help doing that on your practice questions, I can help you do that as well. Now, before I turn you loose for the practice stuff, I do want to show you. Oh, sorry, I forgot to write my conclusion. Sorry, I got ahead of myself here. All right. So we reject the null hypothesis, which is our claim. So there is enough evidence to reject the claim that the breaking strength is 800 pounds. So yes, there is that fifth step, there is that summary step, and I know I've said this probably 5 times already at least. Page 425, guys, is a big help. It takes a little bit getting used to when you're going to write there's enough evidence to reject, not enough evidence to reject, enough evidence to support, not enough evidence to support. Those are your 4 options. Enough evidence to reject, not enough evidence to reject, enough evidence to support, not enough evidence to support. Those are your 4 options. All right, now that we actually finished that one, now I just want to show you the calculator steps. They're on page 437. They're on page 437. We go to stat. We go to tests. And we want option 1. We want a z-test. We want option 1. And I'm just going to go ahead and we'll do it just for our very last question. So we have the stats. Your mu sub 0, that is what your hypothesized mean is. So it's the one in the null hypothesis. So in this case, it's 800 pounds. Population standard deviation, we're told, is 12. The sample mean that the researcher found was 793 pounds. Sample size, he sampled 20 cables. And we have a not equal to. And we'll go ahead and calculate. So what this calculator will give you, it will give you your test value. It will give you your p-value. It will not tell you your critical values. So if you're doing traditional method, it will not tell you the critical values. You need to be able to find those. And it doesn't say reject or not reject. It doesn't say here's your summary. All the calculator shortcut does for you this time, it's unlike the confidence intervals that said, here you go, here's your interval, did it for you. All this does for you is find your test value and your p-value. The rest is still up to you. All the other steps are still up to you. It's not going to write your hypotheses. It's not going to identify your claim. So you can use the calculator.
I think I have 2 kids who lost it.
Okay. So when you do the calculator stuff, and I do have this information on your handout, when you do the calculator stuff, you can't just bank on, I don't need all those steps, everything she wrote up there because I'll use the calculator. It's not like the confidence intervals. Everything is not done for you by the calculator. It'll do the test value for you, and that formula isn't super tough anyway, and it will find p-value for you. That's all it will do, though.